Hi and welcome back. In today's video, I'm going to go through 5 exponential equations solved step by step so you know exactly how to do these if this come up in your test exam. So let's look at the first one. I've got 2 to the power of x plus 1 equals to 32. So the key, if we want to do this without using logs, is to try and make the base numbers the same. And we know 2 to the power of 1 is 2. 2 to the power of 2, 2 times 2 is 4. 2 to the power of 3 is 2 times 2 times 2, which is 8. What about 2 to the power of 4? So that's 2 times 2 times 2 times 2, which is 16. 2 to the power of 5 would be 32. So the reason I wrote that out is because I want to represent 32 as 2 to the power of 5. Because we want the bases to be the same. So we could write this equation as 2 to the power of x plus 1 equals to 2 to the power of 5, because 2 to the power of 5 is 32. Now, because the bases are the same, we could actually just make the exponents, the indices, equal to each other, because if the bases are the same, then the indices must equal to each other. So x plus 1 has to equal to 5. And if you rearrange that, you bring the 1 across, so it becomes take 1. So x is 5 minus 1, which is 4. So well done if you got that correct. Let's use that same principle and go a bit harder. Okay, so the next question is 3 to the power of 2x minus 1 equals to 81. So same thing, what we want to do is represent 81 as that base, as 3 to the power of something. So 3 to the power of 1 is just 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27. Oops, trying to erase that. And 3 to the power of 4 is my 81. Boom. So instead of writing 81, we're going to write that as 3 to the power of 4, because that's what 81 is. So my equation is just, the left-hand side is still 3 2x minus 1. The right-hand side, instead of writing 81, we could write that as 3 to the power of 4. And now, because the bases are the same, you could just say the indices equal to each other. So 2x minus 1 equals to 4. So hopefully you're getting the hang of this now. So if we rearrange that, bring the neg 1 across, so it becomes plus 1. So 2x equals to 5. Bring the 2 across, it's multiplied. So when you bring it across, it becomes divide. 5 on 2. X equals to 5 on 2. So good work if you got that correct. Okay, let's go a bit. Actually, the next one, hopefully we could all get correct now because it's quite simple. 5x equals to 125. So let's just write out all our indices for 5. So 5 to the power of 1 is 5. 5 squared is 25. 5 cubed is 125. So instead of 125, I could just write 5 cubed. So 5x equals 5 cubed, and that just means that x equals to 3. That was nice and easy. Okay, let's go a bit harder. So the fourth one, 4x, 4 to the power of x equals to 8 to the power of x minus 1. Okay, so there's no way we could write a as 4 to the power of something, because 4 to the power of 1 is 4, 4 to the power of 2 is 16, so there's no way we could write 8 as something like that. But 4 and 8 can both be written as 2 to the power of something, right? Because remember, 2 to the power of 1 is just 2, but 2 to the power of 2 is 4, 2 to the power of 3 is 8. So we can have a base of 2. So let's do that. So instead of this 4, I'm going to write 2 squared, because that's what 4 is. So let's do that. So instead of that 4, I'm going to put 2 squared. Let's use brackets, and we still have that x outside. And instead of the 8, I'm going to write 2 cubed, because that's what 8 is. So 2 cubed, and again, let's put that in brackets, and you have that x minus 1 outside brackets. Okay, so hopefully you remember your indices rules. But when you have brackets and you've got indices, you basically just multiply out the indices. In this case, those two will just multiply. So you got 2 to the power of 2x. In this case, that 3 would multiply with that and also that. So 2 to the power of 3x, take 3. And now the bases are the same, so that must mean you could cancel them, or you could conclude that the indices have to equal to each other. Okay, so this one's a bit trickier. So let me bring this -3 to this side and this 2x to this side. So that -3, because I brought it across the equal sign, becomes +3. And my right hand side is 3x take 2x. And 3x take 2x is just x. So 3 equals x, or x equals to 3 for that answer. So yeah, excellent work if you got that one right. And I've got one more, quite easy-ish for us to go through. Let's see if you could get this. So 2 to the power of x, which is squared, equals to 16. Okay, let's give this a go. So same steps, let's just write out all what my 2 to the powers are. So 2 to the power 1 is 2, 2 to the power 2 is 4, 2 cubed is 8, 2 to the power 4 is 16. So instead of 16, I'm going to write 2 to the power 4. So we still have 2x squared, and instead of 16, I could say 2 to the power 4. And now we could just say their indices equal to each other. So x squared equals to 4. That must mean that x is the square root of 4. And never forget this, whenever you square root an answer, you always get two solutions, the positive and the negative. So square root of 4 is either -2 or +2. So x equals either plus or -2. So well done if you got both of those solutions, and excellent work if you got all 5 of those correct. If not, hopefully you understood where you went wrong and you should be able to do it now. Thank you for watching, and I will see you next time.